Good morning, everybody. Welcome to the Hot Glass Show here in the Corning Museum of Glass. We have a special program this morning called Bring the Heat with our own Eric Goldschmidt. He's going to be doing a demonstration that's from now 10 o'clock till noon. So this is a special demonstration that we do every other Wednesday. This is going to be the last one of the season before our summer programming starts. So how about a big round of applause for Eric Goldschmidt?
Thank you. Alrighty, well, welcome everybody. You may have noticed I have sort of a unique mask on. Got this hose attached, and there is a piece of the hosing that goes right into my mouth. So if I start slurring a little bit at different points here, I hope you'll forgive me. But this allows me to actually blow some glass on the torch while still keeping the mask on. And I want to give a big thank you to my colleague and fellow flameworking artist, Amy Lemaire, who came up with these plastic pieces that are 3D printed to allow for the hose to pass through the mask safely. It's a really helpful design. And also I've got this wonderful blow hose and swivel setup by Fire Kissed Glass, who came up with a wonderful hose design that makes this all a pretty reasonable thing to do. So thank you to both of those folks, and I'm going to start diving in here. So what I'm going to make today are one of these tiered serving displays that I've been working on over the last couple of months, and they are somewhat inspired by an exhibition that we're about to open called In Sparkling Company. It's going to open on Saturday, and part of the show illustrates different servingware that was used in England in the late 18th century, and I really enjoyed seeing some of those forms, so I started doing some takeoffs on those forms. These are also influenced by my biggest mentor in glass, Cesare Toffolo, who is a brilliant Venetian glass artist, and so we'll dive in here. So I'm going to warm up my safety glasses a little bit here. One thing we've discovered during these pandemic times is if your glasses are warm, they don't fog up so badly with the mask on. So I just take a torch everywhere I go and I'm all set. So just warm those up a little bit. And one other thing I want to mention as I get started here, this is a very special day in many ways, but the way it is most special is that today is my mom's birthday. So I believe Mom is tuned in down in Florida, and they are headed up north tomorrow. So I finally get to see Mom again very soon. It has been a long time, so happy birthday, Mom. I love you. Can't wait to see you again very soon. And I hope you like these tiered displays, Mom, because you are getting one for your birthday once you get up north. So there we go. So the bowls for these displays, they start as hollow tubing. So I've got a piece of this blue tubing in my hands here. I have a couple other sections of this prepped and ready to go, and I've got them in an oven that's on the other side of the shop here. I'll pull them out as I get on moving along on the different parts. Now, these tiered displays are all separate parts, and they're all sort of built around the foot and a post that comes up from the foot. So I'm going to start with the foot here and get the post attached, and then I'll continue to build all the additional parts on there. Now, this glass, if I heat it too quickly, it's going to tend to crack. So I'm starting with a relatively cool flame here. This is about 1,000-degree flame, so easing the heat into the glass. Now that I've pre-warmed it, we're going to start to add some more oxygen into the flame. This torch is running on propane and oxygen. And when I turn the gases up as high as they can go, the temperature of the flame will get all the way up around 4,000 Fahrenheit, a little bit north of 4,000. Now at the moment, we're a little bit cooler than that. This is probably a little below 4,000, so still incredibly hot. But I just want to get this little handle section here centered, and that's going to be a common theme throughout this. I really need things to turn accurately. If I can't turn the glass accurately, I won't be able to turn it accurately in the flame, so I can't heat it uniformly, and if I can't heat the glass uniformly, I can't make anything uniform out of it. So turning, keeping the glass centered, very important aspects of this. Now, I just need a couple inches of this tube. I don't need to use the whole thing. So we're going to move the heat a little further down the tube, and I'll pull another one of these narrow handle sections off of this. Now, when we're not in a pandemic and I don't have to have a mask on, I would typically just put the glass right in my mouth and inflate it. But of course, with different bits of safety concerns now, we've adapted and moved to the mask with the hose. And many glass blowers, many flame workers are used to using a blow hose, and it's a pretty standard piece of equipment for a lot of folks. It is not for me, so it has taken a bit to adapt to this. So people who are watching, who are used to watching how I tend to work, this is definitely a bit different, and it's a new challenge. It is very much a feel-oriented thing, and having the hose between me and the glass has changed the feel quite a bit, so it's been a lot to get used to. But I still start the process in a similar fashion here. So I'm just going to soften a section here. We call these long, narrow handle sections points. So the action of creating a point we refer to as pulling a point. And that should make some sense as you see how this all happens here. So I want these points to be nice and clean and consistent and straight and as centered as possible. I know a lot of folks who work with a blow hose more often than I do might go about things a bit differently, but I'm so used to using the points, and I'm used to how the point sort of tapers into the rest of the tube. That's been really helpful for me to start by pulling the points first. Now I need to make sure there's always an opening to the tube before I reheat it. If the tube is closed and I get it hot enough, it creates a vacuum and the tube will suck itself in. So I just created a little opening at the end by just scoring the glass and breaking it open. So now I want to make sure these points are centered. So I'm doing a little bit of centering here. I'm also tapering the section a little bit more narrow, and I'm letting the glass thicken up, get a little bit thicker, so it'll be easier to attach another tube on here. Now the end of my blow hose has a very precise, or precisely sized bit of silicone on the end, and that silicone happens to fit this tubing perfectly. This is 9.5 millimeter heavy wall tubing. So I want to get that attached onto the blue tube. That's what I'm going to be connecting to the blow hose and blowing through. So we'll get this point removed and get that clear tube attached. So just giving an idea of all the prep that goes into this. I've already gone through this stage of preparation with a couple other of the pieces that I'll be making to create this whole composition here. So I'm just pulling that really thin, and it's so thin there I can just actually tap right through and it cracks the glass open. So now there's a hole, nice clean hole on this end. And I want to get this to match the diameter of the clear tube that I want to add on here. Now you're going to see me use this tool quite a bit today. We call these jacks. A tool that's been around in glass blowing for a very long time, thousands of years. And just using the jacks to flare the tube a little bit, get it to the right size. So now this other tube will connect cleanly to it. So we'll get this into the blow hose here. I'm going to seal off this end of the tube again. I want it to hold pressure when I go to blow in through the blow hose. Slide the hose a little deeper into my mouth there. So go ahead and get this connected, and I need to blow in a little bit to make sure the wall thickness stays nice and clean with this. Right, so I want this connection to be centered and uniform in wall thickness. Clean that up just a little bit. And then I'll shape this tube into the foot of our serving display. All right. So I'm just going to wait for that to firm up. Now, the glass that I'm working with here, that's what's known as borosilicate. I know a lot of folks come to the glass museum under the impression that all glass is the same. It's all made from the same ingredients, all has the same sort of characteristics to it, but that really isn't true. There are tens of thousands of different recipes for glass out there in the world, and just like a recipe for a batch of cookies or a loaf of bread, if you start changing ingredients in a glass recipe, you wind up with very different characteristics to the glass. And what is particularly notable about this glass here is that it does tolerate temperature change a lot better than most other glasses. Now, it's not completely impervious to stress from temperature change, but it is a lot more tolerant than most other glasses. So I'm just soaking some heat into the tube initially. Come out of the flame, let that heat really penetrate. And now I'm going to heat a little bit more. And once the temperature is just right, I'll come out of the flame and start to inflate this. So gently bringing my hands a little closer together as I'm heating. Get out of the flame.
If any of you folks in the audience have any questions too, you can just get my attention and I'll relay them to Eric. And anybody online also, Amanda is our moderator, so if you have any questions online, we will answer them also.
All right, so I inflated that a little bit. I want to make it just a little more squat on the right side of the form here, so just squeezing in a little bit.
So we have a question in the audience. Mm-hmm. Yes. What temperature does the glass become malleable?
Well, this glass will start to soften at 1448 Fahrenheit. But when I'm really shaping it, we're a little bit above 2000, probably between 2000 and about 2500.
Yes, we have another question. Why doesn't that break the glass, Eric?
Because it is too hot. With this sort of heat, it's just softening the glass, not making it more rigid. So as long as I don't heat it too quickly and shock it.
So Eric has many years of experience, and that is a problem that you have to worry about is thermal shock. And we all experience it as glassmakers, but the more experience you have, the less of a problem that is. Yes, we have another question. He's not wearing any gloves. Is that incredibly hot on his hands?
Well, thankfully, glass is a very poor conductor. So it's not conducting the heat to my hands, so they are doing just fine. And my dexterity is so important for this that gloves would really inhibit that. The turning accurately is so important that I really can't have anything affecting that.
Now, I do see you do have a glove on your bench. It looks like a right-handed glove.
Mm-hmm. Yeah, there are times that I'll use a glove that is a Kevlar glove there, but not when I need to really turn accurately. And to be perfectly honest, that glove, I'm only going to use it to wipe kiln dust off of the glass. So it's essentially a rag. Yeah. So I'm setting up a connection point here. I've set up the shape of the bubble, and I want to attach an 11 millimeter rod to this end of the form here. And that 11 millimeter rod is key to the whole situation because everything else is going to fit perfectly over this rod. As I sort of make each individual part, they slide right over this and fit very cleanly. So just getting the top of the foot shaped up just right here. And we'll get this rod attached. Now, as I go to make this attachment, it's got to be a good one. It's got to be structurally sound, and it needs to be nice and straight and centered. The whole rest of the piece gets stacked up on this, so it's got to be right. Alrighty, so the connection needs to happen at the right temperature so the glass really flows together and makes a permanent seamless attachment here. So I want the glass essentially white hot. And at this point, it's creeping up closer to 3,000 Fahrenheit when it looks white hot. And it's so soft, the pieces just flow together. So you have a nice, clean, permanent attachment that way. Permanent until somebody decides to knock it on the floor. So now I'm just waiting for that connection to cool and stiffen up so it'll hold its shape and hold its position. And then I want to open the tube up and flare it. So we get a nice flared foot like you can see at the bottoms of these two units in front of me here. So just let that firm up a little bit more. So to open the bubble, I'm actually going to crack this thing open, but I want to control how it cracks, of course. So we'll go ahead, we'll get the blow hose off of here. So to control how this cracks, I'm going to create a constriction to control it, what we would call a jack line or a neckline. So just softening the glass where I want to make the constriction, and I'm going to use the bracket on top of my torch here to really carve right in. Get our constriction in here. And now that I've got that constriction, to further weaken this, I'm going to use my diamond shears. And we call these diamond shears simply because the blades close to a diamond shape. There's no actual diamonds on there. So I'm going to soften the tube a little more. And I'll use the shears to tighten the constriction a little bit. But more importantly, I'm using the metal shears, the metal blades, to cool the glass just where they're making contact. And that sets up a little bit of thermal stress in the glass. With enough thermal stress and enough of a vibration, it comes off nice and cleanly. So now I've got a nice round uniform opening. So I just need to continue to widen the opening. So soften up that lip a little bit. Now I'll use my jacks to open this, flare it open a little further. Now the blades of the jacks are steel, and as steel heats up, it'll tend to stick to molten glass. So you'll notice that I keep dipping the blades in beeswax, and that'll keep everything sliding along, works as a very effective lubricant. So now I want to keep the lip, square it off to the rest of the form here. I want to keep it round and centered. But I also want to add a little touch of color, a little bit of a lip wrap on here. So I've got this nice wisteria purple that we will add to the edge. Do what we call a lip wrap, which is quite literally what is going to happen here. I'm going to wrap the lip with this color. I want to make sure it goes on nice and cleanly and uniformly here. I put on a fairly thick lip wrap for these. They're going to get stretched quite a ways as I flare them. So I want to make sure the application of color is dense enough that it holds its vibrancy once it gets flared.
Now, I noticed that you cleaned the tip of the colored rod that you added the lip wrap to. Is that for the shape or just to make it clean?
That actually accomplished both things there. Yeah, I wanted to bring the shape to a point, but also it looked like there might be some little air bubbles on the tip of the rod, so that's why I got rid of that. So now just adding some extra heat so that lip wrap is really fused to the blue.
Is the color a dye or is it a different composition of glass?
Now, dyes don't hold up to these temperatures. So dyes and pigments are out the window when it comes to glass. To create colored glass, different metal oxides and different elements from the Earth's crust are melted in with the ingredients for clear glass. There's a bit of a chemical reaction that occurs when you get the materials hot enough for long enough, and that gives us colored glass. So yeah, they're actual pieces of colored glass that are colored through the addition of different materials.
And recently, there's a lot more color available in the lampworking community, as I understand.
That is absolutely right. Yeah, when I first started flame working 25 years ago, there were maybe 40 colors or so, maybe 50 that were available, and nowadays there are hundreds available in borosilicate palettes. So the community has really grown a lot, and the color manufacturers have really stepped up over the years to make us some fabulous color to work with.
So that was the question, why? What increased the amount of color availability? And I would say demand.
Yeah,
so
absolutely.
Huge demand for different colored glasses. There's a lot more people flame working probably today than there was 20 years ago.
That is quite true. So just getting this flared the rest of the way open here. I want to make sure this is going to sit flat on the table. So we'll check it right on the table here.
So the question is, Eric, we have a question about what companies are creating the colored glass and what makes them decide what color to make?
Well, there are a number of companies all around the world that are making colored glass these days. The tubing that I'm using is coming out of China. And the reason I use this particular tubing is that it's nice and consistent and round and uniform. So for the blown forms that I'm making, it's really helpful stuff. Then some of the other colors I'm using here are coming from companies out in Oregon, actually. And how do they decide what new colors to come out with? You'll have to ask them. I have no idea, but they keep coming out with great stuff. They seem to follow some of the design trends in the flame working world is my best guess. All right, so I've got the foot formed here. Now I mentioned the size of tubing or the size of rod was crucial. It fits the 19 millimeter heavy wall tubing really nicely. So all the rest of the parts, I'm going to have a little bit of this tubing attached to the center of each of these bowls, so they will then just slide right over the top of this. So we'll set that there. So I've got some pieces prepared here. I have little sections of that tubing attached to solid rods. So these are going to become my handles. And I've got some other sections of tubing ready to go that are already pre-warmed in my oven. So I'm going to go ahead and grab one of those. We'll start with the biggest one, that is the bottom bowl. That is the most exhausting one for me to spin out. So we'll start there and work along to the smaller ones as I get more tired. They should, in theory, make my life a little easier. And this is a pretty exhausting piece. I'm definitely pushing the envelope on my skills and what my body can handle. So I'm using the glove as a rag, just cleaning off any kiln dust off the tube. And we'll get this guy attached.
Yes. Are you judging the temperature in the glass solely by the color, Eric?
Yes, I'm watching the glow. And I will feel out the movement a little bit as well, but it's mainly the glow.
Yes. Well, I would say, speaking to the COVID situation, we're here in a public access museum, so of course we're all required to wear masks. Eric was working by himself. You know, this type of lamp working, Eric is doing it by himself. If he was at home by himself, I would assume Eric would take the mask off.
Yeah, absolutely.
So, you know, that hasn't changed. I would just say, you know, in terms of, you know, being exposed to the virus, you don't want to be exposed. So of course he's going to wear a mask if he's working with other individuals or people are watching. But if he's home by himself, I'm probably pretty sure he would take his mask off.
I do, yeah. I only do this here. But I have a studio at home. I don't bother with a mask there. I'm by myself.
Sometimes I forget I have it on, Eric.
I know. And anybody who wants to complain, you should try what I'm doing right now. You concentrate while you get the mask, the hose, safety glasses, and the microphone.
Yes, what's your question? I didn't catch the last part of that. The scientific glassmaking, is that still around?
Oh, it sure is. Yeah. Scientific glass blowing is a very important industrial application of flame working. So I actually have a number of friends and colleagues in the field, and there's still a big need in that field. All right, so I'm really heating up the whole tube here, the whole length of it. I'm sort of gently bringing my hands closer together as I heat, trying to condense the form, make it a little more compact, a little shorter. So I'm going to get this a little bit hotter and I'll start to really inflate it.
Eric, we have a question about how much experience or how many hours do you need before you start making hollow glass on the torch? I know, in an apprenticeship for the Steuben factory, it was 12,000 hours to become a gaffer. That's 6 years. Do they have some sort of an apprenticeship or, an hour long thing before you can start doing this?
Not really. I mean, it's really case dependent. And it seems like people are learning faster and faster these days too. There's so much information out there that people are learning pretty quickly.
How much experience do you have, Eric? How many years have you been making glass?
I've been at this a little over 25 years. Trying to get this a little more spherical. I want to flatten the left side of the bubble a little bit more. Turning a little faster.
Eric, we have a question from the audience. At what point did you decide that you'd like to do this for a living? Did you have a moment where you're like, this is what I want to do for the rest of my life?
Huh. I guess that would have been about 25 years ago. I got started in crafting as a candle maker, sort of building a wholesale candle company with a couple of friends, and they actually still have that company functioning now, but I had a friend move in with me as a roommate who had a couple years experience doing this stuff, and he set up a little studio in our garage at home, and being the curious type that I am, I couldn't resist checking it out, and saw some of the unique possibilities of glass, and couldn't resist giving it a shot. And then I lived in Vermont at that point, and I started coming out here to Corning to take classes through the years, and eventually got a job offer, and I've been here since 2001 at this point. All right, so I've got the bubble set up pretty well here. And now I want to go ahead and open this and flare it. So just like I did for the foot, I'm going to set up a constriction where I need this to break apart. that constriction a little bit here. All right, so we've got a good constriction. Next step is with the diamond shears. My hands sweat quite a bit doing this stuff. So I do have the rag tucked into my back pocket so I can try to dry my hands off as we go.
Now I see that you have 3 different size of these plates. Do you caliper them, or it's the size of the tubing that you start with, so you know that they're going to be incrementally smaller?
It's the size of the tubing that I start with. Yep. I start with 3 separate lengths, so I know if I handle the glass relatively consistently, I'll come out with the right size bowls. I'm just going to open this a little bit further here, and then I want to add a lip wrap, just as I did with the foot. Now, when I just make a regular goblet, I tend not to open the lip quite so far, and I tend to put a much thinner wrap of color on it, because it doesn't need to flare open quite as wide as these bowls do. So for the bowls, I go with a wider opening, and I apply a much thicker wrap of color, because it's going to stretch so far, and I want to maintain that color density. So that's always a consideration. So you try to figure out what you may want to use for a lip wrap. Think about the density of color and think about how much you're going to have to stretch it. So I try to control the thickness of the wrap by how much I pull on it. So now that wrap is on there, again, I want to make sure I really fuse it together. Get a little extra heat on here.
Yeah, yell it right out.
What's the largest or most complicated piece that's broken while I've made it? Was that the question? It might be this one, who knows? That's, I don't know. I think probably one of the most exciting bits of breakage I've had was I was teaching a class several years ago, and I had a really nice Venetian harp stem with a dragon in the center of it, and it's really beautiful, and I finished it, and put it away in the oven, came back the next morning, and the oven got too hot and it slumped, so it was bent. And again, I'm teaching a class doing this, so I figured I'd try to fix it. So I fire up the kiln again, warm the thing back up, I get it into my tools, I go to try to heat it and straighten it, and it just exploded and shot parts everywhere. And as soon as I realized what had happened, I looked around the room and all the students had left. They went running away. So that was a fun one. But who knows, maybe we'll get something more exciting today. All right, so now I want to flare this thing open. And now that I've got the shape set up right, I just need to get the heat set up right. And then I'll use centrifugal force and really start to turn faster and faster. And count on that heat and rotation to flare this the rest of the way. So here we go.
Eric, we have a question online, and is the flame working color similar to the furnace working color in terms of the cobalt will soak up the heat more so than other colors?
I'm sorry, say that again, George?
The question is the flame working color, like cobalt blue, similar to the furnace working colors as that it will heat up faster than other colors?
Actually, no. It's quite a bit different. Cobalt and borosilicate is actually a fairly stiff color. Yeah, so it is quite a bit different. All right, so there we go. There we have our bottom bowl for our setup. Let's set this guy aside here. And now we've got a few more parts to go yet. So I have one other bowl that is the next size up that I want to make. But I also want to make the clear spacer parts, those are fairly simple. So let me grab a piece of that tubing that I've got ready to go here.
So we had a question in the audience, Eric.
Yeah.
They noticed that you're doing everything by eye. Is that something that everybody does as glassmakers, or do you use certain tools to measure? Or like, what if your sight starts to go bad?
Like it is? Hang on a moment. Now, when it comes to measuring forms, there are times that I'll use calipers. And if I really was obsessive about having these all be perfectly measured, I would set calipers for each step of the process. And I'd sort of hang them off the edge of the bench so I could slide the tube through and make sure they hit the measurements. But honestly, for a piece like this, I've made a bunch of these over the last couple of months, and I've got them pretty well down at this point. All right, so these spacer sections are just some what we call conturax tubing. There are actually ridges of different thickness running through the tube. So these I just blow out a little bit, and I will take to a wet saw, so like a tile saw, and I will actually cut the ends so they're nice and clean and accurate there. So that is one of the spacer parts. And to give you an idea of how these things really do assemble, we've got some other parts ready to go here. So we've got a foot already. From the foot, we've got an extra little spacer bit that we put down there. And we've got our big bowl.
So we had a question online, Eric.
Yep.
What's the most fun part of glass making for you?
The most fun part of glass making for me, it's all fun. I mean, flame working for me is really just meditation. It's a really, really peaceful time. It sort of forces me into a certain level of focus that is just a really fun mental space to be in. And I don't know, there are certainly disappointing times when things don't go quite right, but even in those times, I get to shape stuff with fire, so that's not so bad. Yeah. All right, so we'll make the next bowl here.
So we had a question from the audience, Eric, that tubing with the lines in it, the contracts, do you put the lines in it yourself, or does it come that way?
It comes that way. All this tubing is extruded from really big furnaces, so they can extrude with a shape in the center, and it comes out with that nice texture to it. Alrighty.
Eric, we had a question online of why doesn't the parts need to be kept in a garage or in an oven to keep them warm while you do other things like furnace glass?
It's a different composition of glass, and it just tolerates different conditions. This stuff was developed to tolerate temperature change better than soda lime glass, so it just tolerates it.
There are some applications, though, where you probably do use an oven to keep components warm while you make other components to join them together?
That is true. That is true. More complex forms where there are multiple attachments or maybe some more awkward shapes, things like that I might need to keep in an oven. Or if I was going to continue trying to work with the different components to maybe attach them together, something like that, yeah, then I would need to keep them warm. But ultimately with this glass and these forms, they can stay out. They'll tend to be just fine, and I'll anneal them later. All right, so just getting that 19 millimeter tubing attached, so this bowl will also slide over the rest of the construction. And now that that's on there, crank up the firepower a little bit more. So again, when I use this tubing, I always like to sort of preheat it. I soak some heat in there, then I come out of the flame, let that heat penetrate from the surface into the core a little bit, then I'll come back to the flame, reheat the surface until it's really up to temperature to inflate it. So, here we go, just soaking heat. Back out of there, let that heat really penetrate. And then I'll dive back in. A little hotter, gently bringing my hands closer together. Reheat and bloat a little more. Also compact the form a bit. So one of the tougher aspects with these pieces is getting the profile the same on each successive bowl. So just trying to get the left side, my left side of the bubble shaped up the same from one to the next. And that looks pretty good there. I'm noticing we're creeping up on 11 o'clock. And I know my mom has to take off at 11, so Mom, I hope you have a wonderful birthday, and we will be in touch a little later today. And the whole audience here says happy birthday to you, Mom. Alrighty. Go ahead and pop this open here. So same deal here. I want to set up a proper constriction where I want this to break apart. Sort of carve into it with the heat of the flame. And then I use the bracket on top of the torch. Really carve in that constriction. It's important that everything stay round and centered as I do that. Not a haphazard thing. It needs to be precise. Now, if I don't get that constriction area nice and clean and round and centered, the bowl will not come out clean and round and centered either. So every step of the way here, things really have to be consistent.
We had a question from the audience, Eric. Are there any glass blowing competitions for flame working?
Are there any glass blowing competitions for flame working? You mean like blown away? Something like that? There actually is a show in the works that should be coming out any time now that is called Operation Pipe Dreamers, that will actually be a competition show of flame workers making functional pipes, which is also a very fascinating and fast-moving aspect of the flame working world. I'm not sure exactly when that's coming out, but keep your eyes peeled. I think they were going to launch it on YouTube, but I'm not entirely certain where that stands. But yeah, there is a show coming out. Now, there are many other competitions in flame working that occur in different parts of the country throughout the year, but they're not necessarily online. So I know there was just actually a big trade show out in Las Vegas this past week where there were prizes given and pieces judged. I don't think they were made live on the spot, but the finished objects were judged. And there are many what we call flame-offs, different competitions throughout the year across the country. So yeah, they happen.
Are you signed up for any?
Am I signed up for any? I am not. Although these forms that I'm making here, I mentioned to a couple of folks earlier, the first time I made forms like these was back in 2009 for a flame-off competition that I was in with some friends out in Las Vegas. It's the International Hot Glass Invitational, where I made sort of the bowl forms, and I had a couple of friends, or a few friends working with me who made other sculptural aspects to add in. If you are frequent consumers of our live streams here, you might remember David Sandage, who was a flame worker who worked with us a couple winters ago. And he was one of the teammates on, I think we called ourselves Team Centrifugal Force. And David made one of his amazing dragons that actually sat on top of one of these sort of fountain-esque displays. Seemed like an appropriate form for Vegas. So yeah, flame workers compete too. All right, so I've got the lip wrap on there. Again, applying extra heat, making sure it's properly fused. Make sure everything's nice and round and uniform. If it's not uniform before I start flaring it, it's not going to get any better while I'm flaring it.
We had a question online, Eric, about they see that you're turning the pieces all the time. Do you have any negative effects with your hands or your wrists with this occupation?
Carpal tunnel is definitely a risk with this stuff, and yeah, I battle it. I definitely do. I do sort of push the envelope with some of the objects I make, but I try to stretch as effectively as possible, and every once in a while I will wear some wrist support. And also you'll notice when I spin these things out, I use the paddle for support. So I do try to make my life as easy as possible, but yeah, there definitely are some risks. You got to be smart about your body. All right, so I'll set up the heat. Once the heat looks good, we'll start to speed up the turning.
I love watching that part of it right there. That's like...
It's a fun one, right?
We had another question online, Eric, from an 8-year-old kid that said that she was going to be a vet. She wanted to be a vet her whole life, and now she wants to be a glassmaker. Do you have any tips or suggestions?
Start stockpiling food now. Do I have suggestions? Yeah, get some lessons as soon as you can. Get out here to Corning as soon as we get our classes back up and running for in-person classes, and start learning. And if you really want to practice something while you're at home and you don't have any glass or a torch or a furnace or anything, learn to turn things accurately. So if you can just take a pencil and turn it and really keep the tip of the pencil as steady as possible, that will be helpful. Those turning skills are absolutely crucial, and learn to turn from different angles as well. And that at least will give you a little bit of a helpful start, because that's one of the biggest hurdles you have to get over first, is just really learning to turn the glass effectively. And then think about how you're going to feed yourself. All right, so let's see. We've got 2 of the bowls set up. We've got one of the spacers. Now, I have been using some little silicone parts in these to help keep everything nice and steady. Slide that in there. That helps to straighten things a little bit. Spacer in there. And I've also got some little silicone bits on the outside of the glass here that helps to snug it up against the spacer. All right, so we've made it that far through this piece at this point. I need another spacer.
So we had another question online about recycling glass. Do you recycle glass in the flame working shop the same way that glass makers in the hot shop recycle the glass, or how do you do it?
Do we recycle glass the same way they do in the hot shop? Well, in theory, we could. Any piece of glass could be remelted and reformed. But this particular glass is such a high melt temperature glass that they're really, we have, I guess we have 1 or 2 furnaces around the museum here that can go up to temperatures that are necessary to melt this type of glass. But it's really not energy efficient with the little bits of waste that we wind up with. So far through this piece, I have created that much waste. Anything else I can reuse. So these pieces of tubing I'll reuse. Any of these rods, as they start to get shorter, I'll just connect them to one another and I can use it right down to the very end. So thankfully there is very little waste with this process, but yeah, we typically don't recycle borosilicate glass because it's not really that energy efficient. So now it is a bit different from the furnace. All right, so I'll make another one of the spacer sections here.
Yes, you got a question? The question is, somebody wants to know if flame working needs to be annealed.
Does flame working need to be annealed? Well, really, any piece of glass that gets melted should be annealed. So yes. Now, this glass, hang on a moment. Now, this borosilicate glass tolerates temperature change a lot better than most other glasses. So that's how I'm able to get away with just leaving these parts out for now. But there is a whole lot of stress bound in there. So ultimately, I do need to anneal these pieces as well. So they'll, when they're cool to the touch, which they really are right now, I'll just take these and I'll cut off the section of rod. So just scoring that with a diamond impregnated bandsaw blade section there. And we'll just pop that off. And then I'll set this into the annealer and anneal that. And then ultimately, I'm going to take this to the saw and I'll chop it off right about there. So it leaves me with just a little bit of that 19 millimeter tubing that is the right size so it'll slide over the top of the form. So yeah, this glass does need to be annealed as well. But I can get away with not annealing it immediately. Now, if there were more complex forms, then I would be more concerned. All right, so we just got that other spacer done, so we'll add that into our construction here. Another little bit of that silicone in there. Next spacer. All right, and I have one more of the bowls that I still need to make, and the finial. So I think we're going to dive into the finial first and play with a little bit of that. So ultimately the finial, right here, is just a short section of that tubing and then a little sculptural element that goes on top of that. So what I've prepared here is a couple layers of colored glass. The base layer is a colored glass known as Ghost from North Star Glassworks. And Ghost is what we would refer to as an opaline glass. It starts out looking like an opaque white. But as you heat it for different amounts of time, for different temperatures, and also as you adjust the mixture of gas and oxygen running through the flame as you heat it, it goes more and less opaque. It'll go sort of opalescent, semi-translucent. So it makes for a really interesting base layer under a cobalt blue. So that's what I've got going on here. It gives sort of a really ethereal look. I think Ghost is a pretty apropos name for a color that has this effect. And part of what I'm doing with the finials for these pieces, they're very sort of geometric and symmetrical pieces. And I like to sort of contradict that a little bit with the finial and go with something that's a bit more organic. And one thing that I really love about glass is how it does go so fluid and then stiffens up and becomes completely rigid. And I like to show that in my finished work, which these really precise geometric forms really don't illustrate that very well. So I like to get that across a little bit in the finial of these pieces. So I'm going to stretch this out and separate it into two portions.
We had a question online, actually kind of related to that, Eric, and a viewer wants to know if it's true that the hottest part of the glass cools the fastest.
The hottest part of the glass cools the fastest. I don't think that would quite work that way. I would say that it's more based, there are other variables involved in that.
Like thickness?
Exactly. Yeah, so the thicker the glass, the more thermal mass it has, so the more ability to hold temperature that it has. So it's not necessarily about where the glass is hottest, but it's about what can hold the heat the most.
So not necessarily about the temperature, but about the thickness.
Exactly.
Any folks in the audience, do you have any questions? All right.
All right. So these finials are sort of wound up almost looking like choral structures, which was not necessarily the original intent, but I'm okay with the fact that they have worked out that way. So I'm going to sort of build off of this section that's currently in my right hand, but I'm going to go ahead and switch hands here. So as I work, I'm right-handed. I tend to use my left hand really to hold things, or I use it as a turning motor when I'm doing the hollow forms. And then I make the more coordinated moves with my right hand, with my more coordinated hand, hence the switching of hands for these elements. So I'm going to make a series of attachments to build out one of these sections. And the attachments have to happen at the right temperature. So again, I watch the glow of the glass to judge that. I want the pieces to really flow together. And a big part of what I'm after with these forms is really, again, sort of capturing the flowing and then the freezing of the material as it sort of holds shape. So the attachments have to happen at the right temperature. And I also need to watch out for angles. I don't want to leave any sharp, acute angles where the different parts come together. As glass is heated, it sort of swells or expands a little bit. And as it cools, it'll contract or shrink. So if I leave really sharp, acute angles where the different parts come together, as the glass cools and contracts, it will pull apart and crack in those angles. And typically the crack will run through other areas of the object as well. So making these attachments, it seems somewhat haphazard, but there are some important rules that I've got to stick with here. Sort of building out this form a little bit. We'll spend a few minutes on this. I really enjoy sort of representing the flow of the material. I think of a very important glass artist who came from Corning. His name was Harvey Littleton. And he's one of the founders of what we call the studio glass movement. And a lot of his work really seemed to capture that essence of the material, that it becomes really soft and flows and then freezes and holds form. Very unique thing about glass as a sculptural material. I'm really enjoying these colors. I hadn't played with much of the ghost color from North Star, but I've used an older version of that they did call opaline, and some of the other color companies that are out there in the borosilicate world have come out with some other versions of opaline glasses, and they're quite a bit of fun. You get some really nice effects from them without having to really do too much. Continue to build up this form. People often ask us if we know exactly what we're going to make before we light the torch or sit down at the bench of the furnace. Is there room for improvisation? Well, you really do need to have a pretty good plan as to what you're going to make before you light the torch, before you sit down at the bench. But there are some areas where you can improvise a bit. So with something like this, I know the rough idea of what I'm after. I know how I'm going to achieve it. But I'm sort of playing around as I go here too. I am sort of improvising what might go where as I build this. It's sort of fun to not have to be so strict about every little move.
Do you ever switch up your design as far as the patterning that you use? Like you have a pattern in mind and you're going to make a certain shape, and that pattern doesn't lend itself to that shape, or it would lend itself to a better shape or a different shape?
Yeah, these things happen. I do a series of perfume bottles and also some goblets where I do sort of a marbleized pattern. And certain types of patterns, because of the viscosity differences of certain colors, may not work very well. Some colors are going to move more than others at different temperatures. So there definitely are times where I'll adjust a pattern application because of viscosity issues that may happen. What do you got, George?
We have a question online about what centerfire tip are you using?
What centerfire tip? This torch has a number 3 tip. And for those of you who don't speak flame worker, it's just the size of this flame that we're talking about. There are different sizes of center flame tips you can get. The number 3 gives a really narrow flame, whereas a number 5, which I also have in a couple other Carlyles here, will give you a slightly wider flame. So that is what we're talking about there. I sort of like the number 3 because I get a little more variety from it. I can get that super sharp needle of a flame, but if I need a broader flame, I can always add it in with the outer fire on this particular torch.
Talking shop.
Yep. Speaking flame worker. We do have our own vocabularies when it comes to glass in general, and then folks who specialize in different processes, well, they tend to have their own bit of vernacular for that as well. Flame workers have gotten particularly creative in their terminology over the last few years, I would have to say. Even the term flame worker is something that people play off of. Some folks will call a flame worker a lamp worker, which actually stems from earlier versions of the technology. and some folks will call it a torch worker. So yeah, we play around with vernacular quite a bit. All right, we just add a couple more touches onto here. We'll be done with the finial. And then one more bowl to go, and then potentially one other spacer. I never made the bottom spacer, which I go about a little bit differently than some of the other parts. So if we have the time, I'll make one of those as well, and I think we will have the time. Alrighty. So one of the unique qualities of glass, if you heat it uniformly, glass wants to turn into a ball. It wants to turn into a sphere. So I really do count on that for these abstract constructions. Sort of pull a little length of a straight cylinder and then reheat the cylinder and it'll turn into a ball. All right, so I'm just going to get this attached here. This is going to be a handle now. So I can hold the form, and I want to get this form attached onto the end of a section of the tubing that is going to fit over the top of the 11 millimeter rod. And I don't know how tight the camera view is on this stuff, but it's a really interesting color effect. In fact, George, if you want to maybe take this one around, you could show it to the audience.
Sure.
Sort of gets that fun effect to it. And this piece I am going to put right into the annealer as I finish it. It's a very thick solid in certain areas. I'm going to be attaching a solid to a hollow, so it's a little more temperamental than just the bowl forms. So I just want to heat up the end of the tube, get it to close off. And as I get it to close off, it'll also get fairly thick. So I'll have a good thick bit of material to attach this to. So it'll be nice and stable. There we go. Making sure this is aligned nicely here. Melt this apart, get the handle off of there, and then this will go into the oven. I might be able to get away with leaving this out in the open air, but it's not really worth the risk. So get this in the oven. So I mentioned a little bit how glass expands as it's heated, it contracts as it cools. So if a piece of glass is heated or cooled too unevenly, it can pull apart. The different areas expand and contract at such different rates, they'll literally pull apart and crack. So the oven will allow the piece to soak in to the same temperature all the way throughout, and then it'll cool slowly. So that oven will come down over the course of maybe 5 hours or so back to room temperature from the 1050 that it's at right now. And it comes down slowly enough that all that material will cool uniformly from one end to the other, from the surface all the way into the core. So everything contracts uniformly as it cools, and it relieves the stress. So that is a process we call annealing. And it is necessary, really, with any piece of glass that you melt. All right, so I'm going to make the bottom spacer piece, this guy right down there, which I haven't gotten to yet. I wasn't sure if we'd have time, but it seems like we're doing just fine. So I'm going to taper down this open end and close it off. Then set it up just as I have the other sections where I'll add another blow tube onto it. So I'm just going to taper this down a little bit more here. And I should mention this demo piece, if it all comes out according to plan, is actually going to be available for purchase through the shops here at the museum. So shops.cmog.org. And I've got some of my other work for sale there as well. Some different goblets. I made a figurative piece back in September as one of these Bring the Heat demonstrations, and that piece is actually for sale on the shop's website if you're curious. Got some other goblet pieces. All right, so just stretching that out. This right off of here. Prep one of these pieces of tubing. We'll just go right on here. So I like to flare the end of the tube a little bit, makes for a cleaner attachment.
Do you ever have problems with the wax dripping off the jacks and landing on the glass and it sticks to it?
Do I have problems with the wax dripping off of the jacks onto the glass and then sticking to the glass? It happens, but I don't consider it much of a problem because the wax will just burn right off anyways, so yeah, not too much of an issue. Now, what I do have a problem with the wax dripping is on me and my right shoe. I tend to get wax on.
We also have a question from somebody online, if you could show them an annealing flame.
Show them an annealing flame. Absolutely. I can do that in just a moment here. And an annealing flame will look different on different torches too. And annealing flame, what we mean by that is a flame that's cool enough that it's not going to melt the glass, but it's around the annealing temperature of the glass, which for this glass is about 1050 Fahrenheit. And the annealing flame does not give a true anneal. It doesn't really eliminate all the strain in the glass like annealing in an oven will. But what it will do is balance the heat, even things out quite a bit, and relieve some of the stress. So it doesn't relieve all the stress, but it does relieve enough from many applications. All right, so I'm just opening up this tube here. We'll crack that open. I'm just trying to get this hole created, and then I'll show that flame setting. Okay, so annealing flame, I would tend to crank up the gas on my inner flame, remove the oxygen from my outer flame. And you're looking at something about like that. So this is going to be around 1000 Fahrenheit. And depending on how thick the glass is, I can soak the piece in that flame and balance a lot of the heat to relieve some of the stress. Now, it works pretty well for tubing because tubing tends to be thin enough that you can, in fact, balance the temperature throughout it with that flame. But for solids, it's not nearly as effective. But still, as you finish work, it really should be annealed in an oven, so it's a very precise anneal, especially if you're going to sell the work and put it out there on the market. All right, so we'll get this attached here. All right, so that's all hooked up. Just going to inflate the middle of this a little bit. Inflate the ends a little bit. Inflate this other end. Sharpen up the form in the center a little bit. Squeeze a little. All right, now the other spacer pieces I just cut open on a saw because I want those lips to stay the same diameter as the original tube and be nice and clean and level. But the bottom spacer piece, it tapers on both ends. And for me personally, with my skills and the way I work the material, it's easier creating those tapers if I do it hot. Now this Contourex tubing with the ridges in it, it's a little tricky with the jacks. The ridges tend to grab onto the jacks. So as I use the blades, I tend to go pretty deep, so I'm using a wider part of the blade that is less likely to get stuck in those ridges quite so much. So there's a little tip for y'all. All right, so we've got a flare on one end, but I want to do the same on the opposite end. So luckily these claw holders work pretty well at holding these forms.
Eric, we had a question from online.
Alrighty.
They'd like to know if your fingers get used to the heat because you're working so close to the flame.
Yeah, they get used to it, but it's not that hot. Where my hands are is pretty reasonable. So yeah, you definitely do build a tolerance. It's similar to being a chef, but it's honestly not that bad where I'm holding the glass, and the heat does stay pretty well contained within the flame. All right, so now I'm going to pop open the other side here. Really important to set a good constriction in there. It's nice and clean and accurate. So accurate means it's round and on center. So this side flared.
So Eric, people online have noticed the tool you're using to hold the glass and would like to know some information about it.
Okay. Any information in particular, or just
They call it the goblet grabber, so I assume they come in different sizes.
Yeah.
And what's the term for that tool?
So the term is generally a claw holder. And yeah, they do come in different sizes. And there's really not a whole lot to them. They're sort of spring-loaded. You can show the construction in just a moment here. So we've got the spring in here that holds some tension. There's a set screw to hold it at whatever diameter. And yeah, it's just a nice extension of the hand when I can't actually hold the glass there reasonably, but pretty easy to control. These are from Herbert Arnold. They're pretty good. I wish they were better balanced. I'd like a little more counterweight back here on a tool like this. I do have some other claw holders that are a lot longer or that do have counterweights, and those tend to be really helpful. These, since all the weight's on one end, it's harder to turn them more accurately, but these hold the glass really well. So you take the good with the bad.
Any tips on not putting it in the flame or overheating them?
You don't want to melt these. They're very precise tools. So you do, if you're grabbing a piece of warm glass with a metal tool, you want the tool to be warm. So I do just sort of brush them through the flame, but I don't want to get them glowing. If you start getting the metal glowing, get out of the flame, let it cool back down. It's pretty thin wire. It would be easy to melt right through that. All right, so we've got that bottom spacer piece. Now we need the top bowl. So got one last piece of tubing here that we can work with. Want to prepare one of my longer blow tubes. Just looking for one that's nice and straight already. So I'm just going to flare this a little bit. Getting used to using this rail as a little bit of a paddle also. That's something I've been sort of getting used to over the last year or so. When you watch people blow glass at the furnace, they usually have an assistant. So as they're sort of opening the lip, the assistant might be there with a wooden paddle to keep the lip flat. We tend not to have that as flame workers, so using that little metal bracket there to keep the lip nice and straight has been a handy thing. It does take a pretty delicate touch to do it effectively, but it works. All right, so I want to ease the heat into this tube here. So taking a lot of the oxygen out of the flame. Sort of pre-warm things. And now I'll start to add the oxygen back in. Take some of the gas out. So I just want to get this point centered, and I want to play with the taper a little bit. So first we'll get it centered. And I want to narrow down the diameter of the taper, but also thicken the walls. And anytime you see me tilting the glass like this, it tells you that I'm using gravity to get the glass to flow in a certain direction.
We had a question, Eric, online if you use gold and silver in your work.
Do I use gold and silver in my work? Very rarely. I'm guessing this person is talking about fuming with gold and silver. I've made a couple of pieces over the last, 6 years or so that I've incorporated a little bit of fuming. And for those of you who don't know, you can actually take very pure gold or silver, I believe you can use platinum as well, and sort of heat a little bit of the metal up over the torch flame to a point where it will actually start to fume and spray the fume forward. So if you keep another piece of glass ahead of that fume, the fume will then gather onto the glass, and it can be used for different coloring effects. And it is not something I use commonly. I did make a piece a few years ago where I took a piece of a darker blue tubing like this, fumed over it, and then I sealed a piece of the Conturex tubing over that. So it sort of trapped the fume into an interesting bubble pattern between the two layers. But it's not something I do very often. Now, for those of you wondering, the fuming, it does produce potentially hazardous fumes as well. So do not want to be doing an application like that without very good ventilation. So throw our little safety disclaimer on that. So I tend not to do much fuming in this particular setup. I do have a box with HEPA filtering that sometimes if I'm doing something particularly hazardous in an environment like this that's wide open, I might use that, and it's got a snorkel to it so I can put it right up close to where the fumes are. Alrighty. So I'll get this attached so we can blow out the final bowl and finish off our serving display. And I want to attach another section of the 19 millimeter tubing on the opposite end. Again, I just want to adjust the taper so it's just right for attaching the other section of tubing on here. Create a hole on the other end, so pop that 19 mil tubing on there. Flare this. Get this piece attached. up the firepower and blow this out. So again, I'm going to soak the heat in here. Ooh. No, we're not going to soak the heat in that. I mentioned how this glass can be temperamental. There's a good example. If you didn't see that, it just cracked because I tried to warm it a little too quickly.
Eric, we had a question online. If you can use frit in boro like you can with soft glass.
Can you use frit with boro like you can in soft glass? You absolutely can. So for those of you who don't know what frit is, it is crushed up colored glass. So I've been using colored glass tubing, some colored glass rods, but you can also get this stuff in different sizes of frit. So yeah. You certainly can. All right, I'm glad I had this other section of tubing here. To save the top bowl for the last because it should be the easiest component of all this. But sometimes the glass likes to keep you on your toes. So I got another piece of tubing connected here. We got this all fixed up and finished. Let's see if this one wants to behave. Take a little extra time with the annealing flame on this piece. Adjust this taper a little bit.
Eric, we had a question online. They'd like to know if you have any experience doing scientific glassmaking.
Do I have any experience doing scientific glassmaking? Very little. The one school in the United States where you can actually get a certification as a scientific glass blower is a little school down in New Jersey called Salem Community College. And I have been very fortunate that I have good colleagues and contacts there who have given me a few lessons on some very basic things in scientific glass blowing. And so I played around with a few things, but it is certainly not my expertise by any stretch. Alrighty. Try this again. So soak some heat through the tube. Let that soak in. We'll go back for a reheat to inflate. Okay. Bubbles all set up. Let that stiffen for a moment. Get the hose off of here. We'll go ahead and open this and flare it. Diamond shears. this a little bit further. I know more and more flame workers are continuing to try using jacks. And when you do, what I would recommend is getting either standard or medium-sized jacks, whatever fits your hand better. But you want a wider blade. I know some folks look at using cup jacks. And cup jacks have very thin blades, which is helpful at the furnace because the thin blade doesn't steal the heat from the glass as quickly as a thicker blade does. But the problem at the torch is you're working at higher temperatures and you tend to burn the wax off of those thinner blades faster, which is a problem. So you're better off with a thicker bladed jack as a flame worker. So get a lip wrap on. And as these bowls go down in size, so does the lip wrap. They go thinner and thinner with each lip wrap as the bowls get smaller because they're not stretching the lip wrap as far. Make sure that lip wrap is behaving, staying nice and crisp, and square it off, and now we'll finish this thing off. Crank up the firepower. The lip needs to be the hottest. It gets progressively cooler towards the back side of the bubble as the heat gets set up just right. Start turning faster. I also hang the glass down so it starts to fall. And there we go. So that top bowl to our setup. And the finial is in the annealer, cooling properly. But there we go. That is what it takes to put together one of these tiered serving displays.
How about a big round of applause for Eric Goldschmidt? Nice job.
Thank you.
What a fantastic way to bring to close the Bring the Heat series for this season.
All righty.
Right on time. The noon whistle.
There it is. All right, we got it.